Assalamualaikum warahmatullahi wabarakatuh. Today, our team would like to present to all of you about logical equivalence. So, without wasting any time, let's go through one by one. So, first of all, I would like to explain you guys about the table of content. So, for our presentation, we conclude the first one, which is team members. Next, definition. Third, truth table. Fourth, conditional statement, and last one is conclusion. Next, the team members. So for our team, this team consists of 4 members. The first one, myself, Muhammad Iqbal bin Zainuddin, and second, Muhammad Aini Idham bin Farah Effendi, and third presenter, Muhammad Farizwan bin Romzi, and last presenter, Muhammad Faiz Daniel bin Muhammad Fauzi. Next, we will go through to definition of logical equivalence. So, what is logical equivalence? Two statements are said to be logically equivalent when they have the same logical content. The simplest example of two logically equivalent statements are statement P and its double negation, not in bracket not P. In fact, if P is true or false, then so it is double negation and vice versa. It is easy to check whether two statements are logically equivalent by using truth label. Two statements are logically equivalent when their truth value are identical or the biconditional statement is a tautology.
Hello, so I'm going to explain about the truth table. So, what is a truth table exactly? A truth table summarizes all possible truth values of a statement. P can be either false or true. So, that is the truth value of P. So, 1 denotes a true statement and 0 denotes a false statement. So, let's go for the example. Okay, so let's look at one example for truth tables. So first we have 3 variables, which is P, Q, and R. So by following the binary number, we will insert the value for P, Q, and R. So next we look at column A. So it shows that P implies R. So we will insert the values for the P implies R. For the next column, which is column B, it is Q implies R. So we insert the values for Q implies R. For the next column, which is column C, which is A and B. So values for A and B is 1, 1, 0, 1, 0, 1, 0, 1. And for the next column, which is column D, it is P or Q implies R. So it is 1, 1, 0, 1, 0, 1, 0, 1. So we compare the value for column C and column D. It shows similarity. So for the last column, we will insert the values of 1 since every values for C and D is the same. So what is the conclusion from this example? So we can say that C and D is logically equivalent by using the truth tables.
Now, from the conditional statement, we can derive 3 another statement, which is converse statement, inverse statement, and the contrapositive statement. So what is the converse statement? The converse statement is obtained by interchanging antecedent and the consequent, while inverse statement is obtained by negating the antecedent and the consequent. And contrapositive statement is obtained by both negating an antecedent and the consequent and by interchanging them. Let's take a look at an example in the symbolic form. The given statement is, if you stay, then I live. So we did not if you stay as P and I live as Q. So the conditional statement is if P then Q. So in converse statement, we will change if Q then P, which is if I live, then you stay. And the inverse statement, we inverse both of the statement, which is if not P, if not P, then not Q, which is if you do not stay, then I do not live. And the contrapositive is vice versa, which is not Q. If not Q, then not P. So the statement if I do not leave, then you do not stay. So now we will check these three statements are equivalent to the conditional statement. So we will use truth table to determine which is these three statements are equivalent to the conditional statement. So from the truth table, we can see that the conditional statement is equivalent to the contrapositive. So as you can see from the truth table, the conditional statement, the fifth column, which is conditional statement, are equivalent to the 8th column, contrapositive. And the inverse statement is equivalent to the converse statement. So from here, we can say that the if P then Q is logically equivalent to the not Q, if not Q then not P, and the not P then not Q are logically equivalent to the Q if Q then P. So we can say the conditional statement is logically equivalent to the contrapositive, and the inverse statement is logically equivalent to the converse statement. So that's all.
So, for the next example, show that negation of P or negation of P and Q is logically equivalent to negation of P and negation of Q. For the first step, using the De Morgan's law, which is negation P and negation P and Q. Next, negation of P and negation P or negation of Q by the first De Morgan law. Negation P and P or negation of Q by using the double negation law. Negation of P and P or negation of P and negation of Q by using the second distributive law. F or negation of P and negation of Q, because the negation of P and P equal to F. Negation of P and negation of Q or F by the commutative law for disjunction. And lastly, negation of P and negation of Q by using the identity law for F. So it is logical equivalent. So last part, we go through conclusion. So after we give you definition and the example of the logical equivalent, so we can prove that logical equivalent is when two statements have the same true value, or the two statements are provable from one another. Logical equivalent is necessary because tautology and contradiction are essential in proving and verifying the mathematical argument. It helps us to explain propositional equivalence. And that's all from us. Thank you. Bye.